Hi guys, welcome to Math Thingy. Today we will study about set and subsets. Okay, so what is a set? A set is any collections of items thought as a whole. Let's say a set of books, or a set of pens, or a set of papers. A set is like a list, and like each items in the list is called the elements of the set. So let's say we have set S with x so that x is an even number between 1 and 11. So this is how we denote a set. Or we can say this set S is 4, 2, 4, 6, 8, and 10. This is identically the same thing. It's just the difference in the way we say them. So the key aspect of the annotations is that with every set S, we have the element of S, which we denote in any letters. So here I denote it as X. And the semicolon. The semicolon here acts as like such that. And then after the semicolon, it's gonna have some type of property, which is px. And here, our property is an even number between 1 and 11. So there is property. Okay. So in general, a lowercase letter x denotes an item that may or may not be an element of some set. So if x has property px, we gotta denote it as x belongs to S. And in the opposite way, if x doesn't have the property px, we denote it as x doesn't belong to S. That symbol right here denotes belongs to. And this one with a cross out is the opposite meaning, which is not belongs to. So that's how we denote a simple set in math. So now we know about sets. What about subsets? So subset is a smaller list of a set. Let's say, for example, we have two sets x and y. X is like we declare above. X is all the x, which has all the x element that x is an even number. Between 1 and 11. And for y, is all the y elements. Again, we can denote the elements in any variables. That's fine. So y is an integer number between 1 and 11. So as in simple terms, x is we have 2, 4, 6, 8, 10, right? And for y, we're gonna have 1, 2, 3, 4, until 11, right? So now we see every element of x is inside y, which means like every element of x also an element of y. So now we say S x is the subset of y. As is x is the subset of y. We denote it as like this. And this notation right here is the set inclusion relation. But there's another case whereby if all the elements of x is in set y, but not all the elements of y are in x, then x can also understand as a proper subset of y, where we denote. So we see like, because x has 2, 4, 6, 8, 10, y also has 2, 4, 6, 8, 10, but for y, they have 1, 3, 5 thing, but for x, we don't have that. So we can say x is the proper subset of y. So, what is the difference between the subset and a proper subset? So the proper subset is all elements in x are in y, but not all y in x, right? But for in just the subset, we have all the elements x in y, and y can also be in x. So that's the main difference here for the set and a proper subset. So we denote the proper subset as x. Excuse me. Oh, I'm going to use y here. We're going to denote x, the proper subset x of y, like this. And this is called the set relation without the inclusion. So think of this like the smaller or equal sign, and think of this like a smaller sign. Where like the smaller and equals, there's circumstances, there's situations where x and y can be equal. But for the smaller sign, x and y cannot be equal. And one last element is that if all the elements in x are in y and vice versa, which means like all the elements y also in x, we can say that x equals y. So that is kind of common sense, right? Okay, so that's the general knowledge you need to know about set and subsets. Thank you for watching. Thank you for watching this video.